Okay, ladies and gentlemen, let's take a look at number one. Number one, you have square root of 64. Answer to that is wrong. What is it? Plus or minus 8. Why is it plus or minus 8, ladies and gentlemen? That's right. Negative 8 times negative 8 equals 64, and 8 times 8 equals 64. The whole point of a square root is the fact that we're asking what times itself. What times itself? So the square root of what times itself makes the number. And in this case, it would be x times x squared would be x. In this case, you could say square root of 64 is 8 times 8. So the answer is 8. Or negative 8 times negative 8 is also negative 8. There you go. So you have the square roots. Now, let's do square root of 32. What's the problem with the square root of 32? It doesn't come out even. That's right. So what do we need to do to it? Need to break it up. Square root of 32. So what's the smallest thing I can divide 32 besides 1? 2. 2 and 16. Now, some of your teachers would say, ooh, you could break this into 4 and 4. You could, but I don't want you to. Because if you do 4 and 4, then over here you come up with 2, and you come up with a 2, and here you come up with a 2, and here you come up with a 2. And so where are your answers? Well, they're all over the place. I would suggest that you just stick with 2 and 16. What's the smallest thing I can divide 16 by? 2, which leaves 8. 2, and always put the small number on the left, and you'll always find it right there together. So 2, 2, 2. Now, what's the actual square root? What is the actual square root? It's not all that. You have, okay, 2 to the 5th does not work, although let's talk about that just a second. Square root of 2 to the 5th. I'll come back to that. You're looking for, just like up here, pairs of numbers. So I have a pair of 8s, got a pair of 2s. That makes 2. I got another pair of 2s. That makes 2. But what do I have left? It's a single 2. It's left over, so it has to stay under the square root. What is 2 times 2, Bradshaw? 4. So I have 4 root 2. Now, technically, what should I put out in front of this? Y plus or minus? Could these potentially have been negative 2 and negative 2 here? Absolutely. So it's plus or minus 4 root 2. Now, let's talk about 2 to the 5th. Well, here's the thing. A square root, we should already know, can be written as a fraction. What's the exponent fraction that I can write square root as? Do we know? It's like instead of x squared, where I say x squared is x times x, the square root of something is x to the 1/2 power. So instead of multiplying through, we're going and cutting it in half. So if I have to the 1/2 power, what's half of 5, Carson? 2.5. So I have 2 to the 2.5. I agree with Carson. So that means I got 2 squared out front, 2 whole 2's, which is 4, and a 2 to the 0.5, which is 4 square root of 2. The two numbers match still, don't they? So whether you think about them in terms of exponents or you think about them in terms of radicals, you get the same answer. Now, what do I have for this one? Who has the answer to number 3? Kirk, what is it? 10 root 2's. Because I have 6 root 2's plus 4 root 2's makes a total of 10 root 2's. Okay, that makes sense then, doesn't it, folks? Now, what are we going to do down here for number 4? Answer is 9 root 5th? No, it is not. And here's why. I can only combine like terms. Are these two like terms? No, they are not like terms. So the best I can do, unfortunately, is just like that. Just like if I had 3x squared plus 2x, can I put those two together? No, because they're not like terms. In the same way, root 2 and root 3 are not like terms, cannot be put together. All right, what do I do for something like this? Who has a thought? Well, what do I do with a 6 root 3 raised to the cube? Can I give away Can I give away the power?
Yes.
So I say 6 to the third, square root 3 to the third. Do we agree with that? Now here's a problem. What if I have 6 times 6 times 6 times root 3 times root 3 times root 3? Now that's in expanded form. What can I do with 6, 6, and 6? Mark Nathaniel's forehead. Here we go. All right. So 6 times 6 times 6 is 216. What is root 3 times root 3? Root 9. I agree with you, but what is root 9? 3. Now, how come I'm not going to put a plus or minus on this?
Because a negative can't be rooted.
True. And also, we can clearly see what we put together to get the 9, didn't we? Wasn't this a positive 3 and a positive 3? So we got a 3. What about this feller? He's still left over, isn't he? Just like up here, we had that extra root 2. Here we go. So 216 times 3. 648 root 3. So there you go. Now, what we can do is give this power away. The other way to think about it is 6 to the first, 3 to the 1/2. Does that make sense? Can I give the 3 to the 1? Okay. And can I give the 3 to the 3? So I get 6 cubed, 3 to the 3/2. And that gives me 216. I got a pair of them. Leaves a 3 and a 3 to the 1/2, which makes that right there. What do I do here? What do I do here? Square root of 6 times the square root of 8. What can I do? Well, folks, if I had x squared times x cubed, what would you tell me? I would add them. I'd say x to the 5th, wouldn't it? Because if they're adding, we have to have like terms. But if they're multiplying, can I combine them?
Yes.
Yes. So there's my example here. So I have square root of 48. What do I do with the square root of 48, guys? Break it down. 2 and 24. 2 and 12. 2 and 6. 2 and 3. All right. What do I got? I got a pair of 2s. I got another pair of 2s, and this 3 is left over. What do I do with the leftovers? Put them back in the fridge. Okay? 4 root 3. There you go, and it's plus or minus. What do I do down here? Well, Zimmer, what's between the 4 and the square root 3? That's right. What's between the 3 and the root 2? That's right. If things are 3 times 2 times 5 times 7, can I multiply them as 7 times 5 times 2 times 3? Because for all times, I can move them around. 4 times 3 times root 3 times root 2. Can I do that? What's 4 times 3? What is root 3 times root 2? Root 6. And I'm done. There you go. So that's the start of some of your square roots.